Hi, welcome to my channel pibyme Maths. This is WST02. Here we are solving October-November 2022 Statistics 2 paper. In the previous video, we covered question number 1, 2 and 3. Let's look at question number 4 now. The probability that a person completes a particular task in less than 15 minutes is 0.4. Jeffrey selects 20 people and asks them to complete the task. The random variable x represents the number of people who complete the task in less than 15 minutes. So P is 0.4. We can write x follows binomial distribution of 20, 0.4. Find P of 5 is less than or equal to the symbols are very important. The equal symbol. It has an equal symbol here, no equal symbol here. We can split it. We don't need 8, so we take till 7 minus. We need 5, so we can subtract till 4. So I'm going to use the table for binomial cumulative with n is equal to 20, p is 0.4, x is 4 and 7. So here n is 20, 0.4 is the 8th column. So we need the value of x is equal to 4, 0.0510, 0.0510 and then 7 for 7. 5674159 0.4159. So let's calculate this. 0.4159 minus 0.0510. This is the answer. 3649. You don't have to round it to 3 significant figure. Leave it as it is. Let's move on to the next one. Mia takes a random sample of 140 people now. Using a normal approximation, okay? The probability that a fewer than n people of these 140 people complete the last task in less than 15 minutes. Probability of completing it in less than 15 minutes is this. So mu is np, which is 140 times 0.4. Sigma is square root of npq. So npq is 1 minus p. Let's find these two. So 140 times 0.4 is 56. Okay, let's calculate sigma now. 140 times 0.4 times 0.6. 33.6, so square root of 33.6. So when x follows binomial distribution of 140, 0.4, when you approximate it, y follows normal distribution of mu, sigma square. So when they say y is probability of y is less than fewer than n, and the probability is given as 0.0239, right? Apply the continuity correction. You can write it as y is less than or equal to n minus 0.5 is this. Standardize the normal distribution. Z is less than or equal to n minus 0.5 minus mu over sigma square root of 33.6 is this. So using the normal distribution table, I'm going to find the value of n now. So from this step, I can write it as z is less than or equal to n minus 56.5 over square root of 33.6 is 0.0239, right? When we use the bell curve for standard normal distribution, the mean is 0. Z is less than means the area on the left hand side of this point, right? And the value is smaller than 0.5. We know this whole area is 0.5 plus 0.5, total is 1, right? So where will be this value so that the value on the left hand side, area on the left hand side is smaller than 0.5? Definitely it has to be here, right? in order for this area to be less than 0.5. So it's a negative number, right? So we can change it to a positive number here. And these two areas are same, right? So I'm going to write it as z is greater than or equal to, this one z is greater than or equal to. How do we change it to a positive number? Multiply by a negative one. So 56.5 minus n over square root of 33.6 is this. But we can use the table only for the area on the left hand side. So the area on the left hand side of this positive number will be 1 minus of this, which is 0.9761. So from the table, I'm going to find the value corresponding to 9761. So 56.5 minus n over square root of 33.6 is 9761 is here 1.98. 1.98 make n as a subject now. So let's calculate n now. 56.5 minus 1.98 times square root of 33.6. So n is 45. That's all. Question number 5 now. It's a 4-mark question. We have a cumulative distribution given. There is a C here and D here. C and D are constants. Find the value of C. Show that C is 6. Okay, the lower limit is 3, upper limit is 7. We have two conditions. F of 3, the lower limit is 0, or F of 7 is 1, right? So if we want to use the condition f of 7 is 1, there is another unknown here, right? So let's find another unknown now using the condition f of 7 is equal to 1. So we replace 7 in the place of x and equate it to 1. So 1 is equal to 1 minus 1 over 6 d minus 7 whole square. 1 minus 1 is 0, 1 over 6 comes here 0, you will get d is equal to 7. Okay, but our aim is to find C. Then why we calculated D first? Because there is one more unknown here. That's why we calculated D first. So it will be easy for us to find C now. C is here, so when you sub in C in the place of x, that function will be equal to sub in C in the place of here, this function. These two functions are same at C. So that's what we are going to do. Put C here. So C over 3 minus 7 over 6 is equal to, put C here, 1 minus 1 over 6 times d minus C whole square. And then make C as a subject. So I'm going to multiply throughout by 6. So 2C minus 7 is 6 minus 7 minus C whole square. Okay, I have put the equation here, open the bracket. 2c minus 7 is equal to 6 minus a square minus 2ab plus b square. A square minus 2ab times minus plus 14c minus c square. Move everything this side, you will get c square minus 12c. This is minus 43 comes here, plus 43 minus 7 is plus 36 is 6. So that's c minus 6 whole square is 0. C is equal to 6. We got the value of C already. Let's move on to part B now. Find x is greater than this. P of x is greater than 3.5 is same as 1 minus P of x is less than or equal to 3.5. We can write this as a cumulative function, right? F of 3.5. Look at the cumulative function here. 3.5 is in here. So we need to take this function, replace x by 3.5. 1 over 6 x minus 3 whole square. 1 over 6 x minus 3 whole square. So get the value of this. 1 minus 1 over 6 times open bracket 0.5 square. 23 over 24 is the answer. Part C now. It's a conditional probability. Take it as A and B. So it's going to be probability of A intersection B. X is greater than 4.5. Intersection 3.5 is less than X is less than 5.5. Divided by P of 3.5 is less than X is less than 5.5. The intersection of these two is going to be 4.5 to 5.5 divided by 3.5 to 5.5. Let's find the probability separately. You can split it as P of X is less than or equal to 5.5 minus X is less than or equal to 4.5. Don't worry about the equal symbol and all because it's continuous random variable. Divided by X is less than or equal to 5.5 minus X is less than or equal to 3.5. So you can use the cumulative. Capital F of 5.5 minus F of 4.3 divided by, it's a 4.5. Capital F of 5.5 minus F of 3.5. So we need to calculate these values. We have capital F of, nothing here actually, this is greater than, never mind, we'll take the cumulative. F of 5.5 is, C value is 6, 5.5 is here. So you need to take this, replace X by 5.5. So X over 3 minus 7 over 6. X over 3 minus 7 over 6. That's basically F of 5.5. Minus, okay, denominator also 5.5 over 3 minus 7 over 6. Minus. Let's find F of 4.5. To find 4.5 also we take the same function because 4 also here, right? So it's 4.5 over 3 minus 7 over 6. And then let's find F of 3.5. For 3.5 we need to, 3.5 is here, we need to use this function 1 over 6 x minus 3 whole square. 1 over 6 x minus 3 whole square. You calculate this, that's going to be the answer. Okay, the 7 over 6 can be cancelled. 5 over 5 over 3 minus 4, 5.5 over 3 minus 4.5 over 3 is 1 over 3 divided by, I just need to calculate the denominator now. 5.5 over 3, 5.5 over 3 minus 7 over 6 minus 1 over 6 times 0.5 square is 5 over 8. You're going to get 3 will come down, 8 will go up. 8 over 15 is the answer. That's all. Question number 6 now. A bag contains large number of counters with one of the numbers 5, 10, 20 written on each of the item in the ratio 5 to 7. So the total ratio is 5 plus 2 plus 5 to A. So total ratio is 5 plus 2 plus A is 7 plus A. So for 5 it's going to be 5 over 7 plus A. For counters with number 10 written on it, it's going to be the ratio is 2 divided by the total ratio. For 20, it's A divided by the total ratio. Okay, that's a bag actually. And another jar contains a large number of counters with one of the numbers 10, 5 or 10 written on it, each of them in the ratio 1:3. The total ratio is 4. So P of 5 is 1 over 4. P of 10 is 3 over 4. Let's read the question further. One counter is selected at random from the bag. We are selecting 1 from this. Out of 3 we are taking 1, and then we are taking 1 counter from here, and we are taking 2 from here. 2 counters are selected from the jar. The random variable R represents the range of the numbers on the 3 counters. The range means if you put the numbers in ascending order. For example, let's say I'm taking 5 from the 10 from the first counter, 5 from the 2 counters from the second one, right? So you put them in ascending order. The range is bigger number minus smaller number. 5 is the range. That's what they are saying. Okay. The range of the numbers on the 3 counters. That's what R represents. R represents the range. Given that R is equal to 15, given that P of R is equal to 15 is 63 over this, by forming and solving an equation in A, show that A is 9. Okay, you need to understand what do they mean by R is equal to 15. The range is 15. So when do you get the range 15? You need to have the first number as 5, the last number as 20. Then only you will get the range 20 minus 5, 15, right? Using the combination of these numbers. You cannot take any other 2 number. You won't get the range 15, right? Okay, so you need to have, we are taking 3 counters and you need to have a number 5 and 20 in it. Now, listen to me carefully. We are taking 1 counter from the bag. So it has to be 20. It has to be 20, right? And then we are taking 2 from the jar actually. So it can be both 5, 5. You will still get the range 5, range 15. Or it can be 5, 10 or 10, 5, right? The first has to be 20 for us to get the range 15, right? You cannot take 20, 10, 10 because the range is not 10. Range is not 15, it's 10. So only 3 combinations, right? So we are going to find the probability of the combination. These two are same actually. You have a 5, a 10 from the jar and a 20 from the bag. So you can write it as this one, the probability is 2 times, I'm taking this, that's why I put 2 times. The probability of 20, which is A over 7 plus A, times the probability of 5 and 10, not from here, from the jar actually. So 1 over 4 times 3 over 4 plus. Now this one, the probability of 20 from the bag times 5 from the jar, 1 over 4 times 1 over 4. This is equal to 63 over 256. Hope you understand this. There are 3 combinations that will give you the range 15, because here the bigger number minus the smaller number 15, here also 15, here also 15. So you need to find the probabilities of them, equate to the given number. Now we are going to make A as a subject. So you can write it as 2A over 7 plus A times, 2 times 3, 6A over this 16 times 7 plus A. When you multiply all the numbers in the denominator, plus A over 16 times 7 plus A is equal to 63 over 256. So you will get 7A because it has a common denominator. 16 times 7 plus A. So 16, okay, wait, 256 divided by 16, okay. So I'm not going to open the bracket. 256. When you bring 16 to the other side, you can cancel this, you will get 16. When you bring 7 to the other side, 7 becomes a division, 9 sevens are this. So we have A divided by 7 plus A is 9 over 16, cross multiply. 16A is 63 plus 9A. They want us to prove A is equal to 9, right? So bring the 9 here. You will get 7a is equal to 63, a is equal to 9. It's a 3-mark question. Let's move on to part B. It's a 6-mark question. Find the sampling distribution of R. First, I'm going to take all the combinations. Okay, let me put the probabilities here. What does this means? We are taking 3 counters, 1 from the bag, this is the bag, and 2 counters from the jar. So if we take 5 from the bag, what are the combination of 2 counters you can take from the jar? It can be 5, 5, 5, 10, 10, 5, 10, 10. By keeping the first one as 5, because the first one is from the bag. We got 4 combinations. Now we can write the same combinations when we take 10 from the counter, 10 from the bag, or 20 from the bag, right? So what I'm going to do, I'm going to copy this whole thing. I'm going to copy it here twice. And here, instead of 5, I'm going to use 10 with the same combinations. And then 20 with the same combinations. So total of 12 combinations we have. Now let's find the range of every single thing. Now the range of the first one, bigger number minus smaller number, 0. Here it's going to be 5. Here it's 15. This is 5. Here it's 5. Here it's going to be 15. 20 minus 5. 10 minus 5. 10 minus 5. 10 minus 5. 10 minus 10, 0. 20 minus 10 is 10 here. 20 minus 5, 15 here. So what are the values R takes? Can be 0, 5, 10, 15. So we need to find the probability of 1 by 1. You don't have to find the probability of R is equal to 15 because it's already given in part A, 63 over this, right? So we need to find the rest of the probabilities 1 by 1. For example, P of R is equal to 0. How many combinations that gives us 0? This one, and then the range is 0 here. For the first one, the probability is the first 5 comes from the bag. So it's 5 over 7 plus A. We know A value of A is 9, right? So just write it as 7 plus 9 is 16. No. 69 over 16. So it's 5 over 16 times. The other 2 5s are coming from jar actually. So 1 over 4 times 1 over 4 plus. So we are done with this. Okay. And then the next, okay, we are done with this. And then the next one, 10, 10, 10. The first 10 comes from the bag. So 2 over 16 times. The other 2 10s are coming from the jar. 3 over 4 times 3 over 4. We are done with this also. So let's calculate this first. 5 over 16 times 4 times 4, that's a common denominator. So in the numerator we can write 5 plus 9 2s are 18. We get 23 over 256. 23 over 256. So we know these 2 probabilities now. Let's find the probability for 5 and 10 now. Okay, I have copied the whole thing here. Now probability of R is equal to 10 now. How many combinations with 10? Range 10. That's just only 1, right? So 20 comes from the bag. So 9 over 16. Other 2 10s are coming from the jar actually. So 3 over 4 times 3 over 4. Now P of R is equal to 15. Sorry, not 15. 5 actually. 15 we have 15 here already. We can take this value. Now we need to find P of R is equal to 5. Okay, we are done with this also. 10 also we have already calculated. 15, it's already given in the question, so ignore them, ignore the 15. The rest 6 combinations of 5. So look for similar combinations with the first 5. These 2 are similar combination, right? The first one is 5 from the bag, so 5 over 16 times the 5 and 10 are, this 5 and 10 are coming from the job. 1 over 4 times 3 over 4 plus. Don't ever think that this, if you see 2 5s 10, this is also a similar one. No, because the first 10 is coming from the bag here. Okay, we are done with these 2. And then is there any other similar one? These 2 are similar also, right? First 10 is coming from the bag, so 2 over 16 times 5 and 10 are coming from the job. So you need to write it 2 times, right? Because 2 similar combinations. Plus. So we are done with this also, right? And these 2 are separate one. The first one is 10, which is 2 over 16, and 5, which is 1 over 4 whole square plus. So this is over. And then this one, 5 from the bag. So 5 over 16 times 10. That's 3 over 4 whole square. So we need to calculate these values also. So let me calculate this 10 first. 9 times 3 times 3 over 16 times 4 times 4. 81 over 256. 81 over 256. Okay. When you draw the probability distribution table, you put small r, P of capital R is equal to small r. That's how we write it. So what are the values R takes? From here, 0, 5, 10, 15. 0, 5, 10, 15. For 15, the answer is given in the table. 63 over 256. 63 over 256. For 10, it's 81 over 256. For 0, we calculated here, it's 23 over 256. So if you add up all 3, subtract from 1, that would be the answer for 5. Okay, but still, just to make sure these combinations are correct, let's calculate this now. So 2 times 5 times 3 over 256, 16 times 16. I think all the bottom denominator are 256 actually. So what I'm going to do, just put it as a common denominator plus. The second one is 2 times 3 times 2. 2 times 3 times 2 plus. The third one is just 2 plus. The fourth one is 5 times 3 square. 89 over 256. 89 over 256. And the next important thing, in a probability distribution table, sum of all the probabilities should be equal to 1. We always need to verify that. So 23 plus 18, I'm just adding the numerator to make sure it's 256. 63 is 256. 256 over 256 is 1. So our distribution table is correct. So we have to verify that. That's all. Question number 7 now. The continuous random variable x is uniformly distributed over the interval a comma b. Given that p of 5 to 13 is 1 over 5, e of x is this, find this. So we need the value of a and b first, right? Okay. So I'm going to draw a little diagram of this PDF function. This is f of x. And the x-axis is just x-axis. We don't know where an a and b are. It can be both positive number or negative number, one positive, one negative. So let's just assume that it's here. This is a, this is b. Now the area between 5 to 13, let's say 5 is here, 13 is here. Definitely it won't be outside the interval. The area between this is given as 1 over 5. We know this point is from the definition of this PDF function 1 over b minus a, right? So we can write this as the area of this rectangle. At the bottom, it's the length is 13 minus 5 times the breadth of the rectangle is 1 over b minus a is 1 over 5. That's basically 8 over b minus a is 1 over 5. You cross multiply, you'll get b minus a is equal to 5/8 of 40. That's equation 1. E of x is 9. The formula to find E of x is b plus a over 2 is 9. So b plus a is 18. That's equation 2. So equation 1 plus 2 gives you the a will be cancelled. 2b is 58. b is equal to 29. Sub in the value of b into any one of the equation. From equation 2, 29 plus a is 18. So a is minus 11. So a is not here, it should be here because it's a negative number. So we got a and b. Now sub in here and calculate this. Okay, so I'm gonna redraw the function again. Minus 11 to 29 now. Let's say this is 29. This is minus 11. This is the actual function now. So when they say p of 3x is greater than a plus p, that's basically 18. So divide by 3, you will get x is greater than 18 over 3, 6. So basically you need to find the area from 6 greater than 6. So this area. So what would be this point? 1 over b minus a. b minus a is 29 minus of minus 11 is 40. So this is going to be, this point is going to be 1 over 40. So the area is this length from 6 to 29. That's 29 minus 6 times the breadth of the rectangle 1 over 40. That's basically 23 over 40. Cannot be simplified further. That's all. Let's look at double I now. They're talking about another variable y is uniformly distributed over the interval 1c. So I'm gonna draw the little diagram. This is f of y and then the y-axis here. The function is from 1 to c. So definitely c should be a positive number because it should be greater than 1, right? 1 to c. Variance of y is this. The formula to find the variance of y is b minus a whole square over 12 is 0.48. This is a, this is b. So it's c minus 1 whole square over 12 is 0.48. c minus 1 whole square is 12 times 0.48. That's 144 over 25. c minus 1 square root of this is 12 over 5, right? Because 12 square is 144, 5 square is 25. c is, okay, square root of answer plus 1. That's 3.4. This value is 3.4. Okay. Now they want us to find e of y square. Let's find e of y first. The formula is b plus a over 2. These formulas are given in the data booklet. So it's 3.4 plus 1 over 2. 4.4 over 2 is 2.2. And then use the formula for variance of x. Variance of y. Variance of y is e of y square minus e of y whole square. So when you rearrange it, e of y square is variance of x, variance of y, which is given here, and e of y we just calculated minus 2.2 whole square. Sorry, minus becomes plus when you bring it to this side. So 0.48 plus 2.2 square. 5.32 is answer. Triple I now. A wire of length 20 cm is cut into two pieces at a random point. Let's say you have a wire of length 20 cm. This is, let's say, 0. We are going to cut somewhere, okay? So let's say the middle point is 10. You cannot cut a 10 because you are going to get two equal half. They want one smallest and one longest piece, because we are going to take the longest piece then cut into two equal length again, right? So either you cut on the left hand side of 10 or on the right hand side of 10, right? So you are going to cut anywhere. Let's say you are going to cut left hand side of 10. This is W. So first you need to write W follows uniform distribution of 0, 20. Now, so in this case, this is W, this is 20 minus W, right? So you take the longer piece and cut into two equal half again. So you're going to get 20 minus W over 2, 20 minus W over 2. Okay, you got three pieces. We don't know which one is the shorter piece actually. The question says, the shorter piece, find the probability that the shortest piece is less than 6. Let's say this is the shortest piece. So W is less than 6, right? Or less than 6. Or 0 to 6, right? Less than 6 means 0 to 6. Or let's say this is the shortest piece. That means 20 minus W over 2 is less than 6. So you will get W is greater than 8. You get two conditions. Okay. Now, I'm going to start from the beginning again. Let's say you have 10 here. We cannot cut at 10. We have cut at the first piece on the left hand side of 10. Now we are going to cut here on the right hand side of 10. Let's say here. And this is W now. This is 20 minus W. And the longer piece is W. We cut them into two equal half again. W over 2. W over 2. Right? Okay, let's say this is the shortest piece now. We need to find the probability that the length of the shortest piece is less than 6. So we'll get W is less than 12. Let's say this is the shortest piece. 20 minus W is less than 6. W is greater than 14. Greater than 14 means it can go up to 20, right? And then these two inequalities, you can put them together, 8 to 12. Right? What does that mean? I will explain the whole thing again now. To get the shortest piece less than 6, you can cut anywhere between 0 to 6. Just imagine you cut here 5. This piece is length 5. The rest of the length, the longest piece is 15 of length 15 centimeter. Divide by 2. You'll get 7.5, 7.5. This becomes the shortest one, right? So to get the shortest piece, the length of the shortest piece less than 6, you can cut anywhere between 0, 6. Or you can cut anywhere between 14, 20. Let's say 14, 20. You cut at 15, let's say. So this is 5, right? So the balance one is 15. So when you divide into half, 7.5, 7.5, you get the shorter one less than 6 centimeter. Right? Okay. Or you can cut anywhere between 8 and 12. Let's say 8 is here, 12 is here. You can cut anywhere between here also. Definitely you cannot cut at 10 actually. So apart from the 10, you can cut anywhere between 8 and 12. So let's say you cut here 9. So this length is 9. The balance one is 11. Half it, you get less than 6. Or you cut at 11, let's say. So this is 11. Balance length is 9. 4.5, 4.5. In every case, we are getting the length of the shortest piece is less than 6, right? So now we need to write the probability So the probability of shortest side less than 6 is equal to, it's 0 to 6 plus 8 to 12 plus 14 to 20. There are 3 possible combinations. And this might be bugging you. We cannot cut a 10, right? 10 is right in the middle. We are talking about continuous random variable. So when we find the area, you ignore the point 10, you are going to get the same, because you are going to take the area on the left hand side, right hand side, add them, you are going to get the same value. So do not worry about it. So if I draw the PDF function f of w and w here, 0 to 20. 0 to 20. The first one is the area between 0 to 6. This area. We know this is 1 over 20, right? 1 over b minus a. So it's going to be 6 minus 0 times 1 over 20 plus the area between 8 to 12. 8 is here, 12 is here. 8 to 12, the area between 8 to 12. That's 12 minus 8 times the breadth of the rectangle plus the area between 14 to 20. This area. So it's 20 minus 14 times 1 over 20. So you can keep 1 over 20 as a common factor. You will get 6 plus 4 plus 6, which is 16 over 20. 4 4s are 16, 5 4s are 20. That's the probability, that's all.